Here's 3810. A ruby laser beam, wavelength 694.3 nanometers, is sent outwards from a 2.7 meter diameter telescope to the moon, 384,000 kilometers away. What is the radius of the big red spot on the moon? Well, in general, for a telescope like this, our minimum angle of resolution is going to equal 1.22 times the wavelength in the medium, in this case air or vacuum, over the diameter of the telescope. And in this case, this minimum angle is going to be approximately equal to the sine or tangent of that angle as well for small angles. And that's going to be equal to what? Well, if we look at this situation where we're projecting a red dot on the moon, we have an angle to the outside of that dot from the center of the dot, and the radius of that dot would be the distance upward from that angle. With the distance to the moon being L, we can see that the tangent of theta is equal to y divided by L. So for small angles, theta itself will be equal to y divided by L. So we can say that y divided by L is 1.22 lambda over d. We want to find y. That would be the radius of the red dot. So solving for y will be equal to 1.22 lambda L divided by d. So in this case, that is going to be 1.22 times the wavelength, which is 694.3 nanometers times 10 to the minus 9. L is our distance to the moon, 384,000 kilometers, which would be 3.84 times 10 to the 8 meters, all over the diameter of our telescope, 2.7 meters. And what do we get from all that? $120.5 meters. So the radius of the big red spot on the moon is 120.5 meters.